So hi guys, from this video we're gonna start a new lecture series on propagation and antenna. So my name is Yugul Nopani and this lecture is solely focused for IOE students. But if you are from any part of the world, this lecture also acts as an equivalent for you. So let's start. So the chapter 1 is about radiation and antenna fundamentals. So if you have any doubt, you can leave in comment section. So if it's in green color, remember it's in exam. If it's in yellow, it's important for IOE students. So let's start. Antenna basically means, okay, I've kept two figures here. This is also an antenna. This next figure is also an antenna. The first figure is about Apollo era antenna talking to Voyager 2. So next figure is also antenna. In this lecture, we'll talk about a lot of things in antenna. So let's start our first video, which is talking about basics of antenna. So what is antenna according to you? So let me describe it easily. As per IEEE, means for radiating and receiving radio waves. We are basically radiating or receiving radio waves. So let's talk about this in a physical dimension. Antenna is converting the electrical power into electromagnetic wave. Basically, it's converting electrical power into electromagnetic wave, or we can also say, as per IEEE definition, it's radiating and receiving radio waves. Or here's the first definition that I've given, defined as the transitional structure, the transitional structure between free space, which means, yeah, you can understand, and guiding device like twisted pair, coaxial cable, waveguide. So it's like from the physical medium, we're converting it into, in a free space, we're converting it into electromagnetic wave, or vice versa, because it can be anything, radiating or receiving. The antenna can be radiating or receiving. So this is basically the thing. There is a source, there is the transmission line that I just mentioned, and there is an antenna, and there is the radiated free space wave. So let's convert these antenna into Thevenin equivalent, because you can convert in Thevenin equivalent. So we'll talk about standing wave in the lecture. It's not like compulsion that you have to mention standing wave here. Okay, there is source, there is transmission line, and there is antenna, like the thing I mentioned above. So VG, okay, let's explain the terminologies first. VG is the voltage source of the generator, and RL is the load resistance, which is used to represent the conduction and dielectric losses, and RR is used to represent radiation resistance, this radiation resistance, and radiation by the antenna, and XA is used to represent imaginary part of the impedance. Why we are representing it into imaginary part is because it represents the stored energy. It comes from electrical and the magnetic field, because of the electrical and magnetic field in the antenna. XA as an imaginary part of impedance is also available. ZA that I mentioned, like ZA is the equivalent of the load antenna, means RR plus RL plus JXA. This part is the part of antenna. So when we mention it as an equivalent, it becomes RR plus RR. RL means load resistance from plus RR plus JXA, which means the imaginary part which stores energy. And regarding JG, we mentioned impedance of generator, because this part is generator, and JC means impedance of the transmission line, which you can mention here also, but it's not as equivalent as that. So okay, this will be easy. So you can JA can be here as well. And let's talk about impedance matching. So what do you mean by impedance matching? When we make impedance of antenna equal to that of transmission line, impedance matching happens, that is maximum power is transmitted. I've just mentioned impedance of antenna. Impedance of antenna is JA. When you equal this and this, when you try to make the JA, the impedance of antenna, and the impedance of transmission line, impedance matching happens, which means maximum power is transmitted. For our antenna to transfer maximum power, we have to include this and this resistance, or impedance, to be equal. Mathematically, J is equals to JC is equals to JG, meaning if the impedance of the part that we have mentioned just of generator, of of transmission line, and of antenna, we have successfully transmitted power. But there are various problems that can arise if impedance matching does not happen. Standing wave can form. I've highlighted this in the below. I'll just come to it. Standing wave can form. Just remember it for now. Maximum power is not transmitted. Have just happened. And arcing can happen. Okay, so just remember it now. I'll explain it properly. So here is the transmission line impedance, which I've mentioned. It's B by I, which is inversely proportional. V is inversely proportional to 1 by C, and I is inversely proportional to 1 by L, meaning that you can just equate and have this, and this is also the formula. You can just memorize it because it's not as that important. And the thing that I've mentioned here is I've like highlighted here. This is the diameter, and this is the distance between, and this is the dielectric constant of the material, and a lot. So let's talk about VSWR, because these are just the terminologies I'm including for your understanding to be strong for the subsequent lectures. Indicates quality of impedance matching, meaning voltage standing wave ratio, which is also equivalent when we represent in mathematical form, is equals to maximum power upon minimum power. It indicates quality of impedance matching. How, you must ask? So if we talk about it, if it is equals to 1, it is perfectly absorbed, and if it's equal to 2, it's reflected back. It's reflected back. If it's 1, it's perfectly absorbed. The maximum power is perfectly absorbed. If it's greater than 1, as I've mentioned here, it's reflected. And this is the standard value. We can mention it. 1.41 is the standard value for VSWR. So maximum power transfer happen when antenna impedance matches transmission line impedance. This is called conjugate matching. You can write JG is equals to JC is equals to JA that I've just mentioned. And if it's not matched, power reflects back, causes standing waves, reduce efficiency. I've written it twice. I'm sorry. So let's talk about standing wave that I've just highlighted. Standing wave occurs when waves reflect back from the antenna. When waves reflect back from the antenna, there is transmission line, there is antenna, and when the transmission line transmits the wave and it gets reflected back, standing wave is formed. How? When forward and reflected waves mix. You can just go and search standing wave in a rope in YouTube, and you'll see this beautiful lecture when you can like clearly visualize what standing waves is. There is two person, and they are like just vibrating the rope together, and you can see the standing wave forming there. So similar thing happens here, but it happens because of forwarded and reflected waves mix, because of VSWR being 2 or higher values than 1, and we have not mentioned it properly. Too much standing waves means stores energy instead of radiating. It stores energy in the form of standing wave, causes sparking. What do you mean by sparking? It means electricity discharging through air in the transmission line. So creates high and low energy points on the line. When you see that video, you can like just explore. It will form like this, and you can see, I mean sorry, not like this. It will form like this, but this will go up and this will come down, and in the subsequent part it will just be in a repetitive manner. So that's standing wave, which is not as desirable as you need. So gliding device used to transport electromagnetic wave from a transmitting source to the antenna, or the antenna to the receiver. We've just mentioned gliding devices are of two types: transmission lines and free space. And if we are classifying transmission line as cable, coaxial cable, waveguide, we can classify it on the basis of the megahertz, on the basis of the frequency, and free space, the space with here. So what is waveguide? Yeah, transmission line is of three types. So what do you mean by waveguide? Is in a waveguide, there is no central conductor. There is no central conductor. Energy travels as electromagnetic wave, and electricity and magnetic field propagate inside the hollow space. So yeah, that's it. That's the definition of waveguide. So that's it for the video. If you have any confusion, you can mention down in the comment section.